this one and say the outside temperature is going to stay the same, that colour is going to stay the same, the energy is going to go from the cup of coffee to the surroundings, and so the temperature is going to fall, and what's going to happen is it's going to fall quickest at first. Let's have a look. See? The arrow energy is going from here to here until they end up at the same temperature, the same colour, and the arrow was fat at first and it got thinner and thinner, meaning that most of the energy went first and then less and less as the temperature difference got less. Oh, let's have a look at the graph, and you can see here just what we said. And again. Okay, it's another situation. Here we've got a cold can of cola left in a room. The object temperature then will be about 5 degrees for a can of cola. 5 degrees Celsius. Put that there. The surrounding temperature will be about the same as it was. That's 20, 22 degrees Celsius, something like that. Let's check those answers correct. Correct. And again, same question to you. What will happen to the temperatures in this case? Which way will the energy flow? And when will the energy flow be the fastest? Okay, let's have a look at the graph first this time. And if we press the run, the arrow's going into the cola this time. That's interesting. The outside temperature hasn't changed because it's so big, but energy has gone into the cola. The cola has got warmer until it's the same temperature as the surrounding. It's just got warmer, and the arrow goes always from dark to light. And just like before, it's thickest at first and then gets thinner and thinner and thinner and thinner until there's no energy flow and the temperature of the cola just stays the same. We haven't plotted the temperature of the room because it will just be a straight horizontal. Okay, this next one is an egg at room temperature put into boiling water. Now, let's do this slider thing first of all. The egg is at room temperature, so it's going to stay where it is, just below 25, 22, 20 degrees, something like that. But this time the surroundings is 100. Very hot. You can see the dark green there. Just check those temperatures are correct. Correct. But what I'd like you to do now is to describe to your teacher what will happen to the temperatures. Which way will the energy flow? And when will the energy flow be the fastest? Good luck. Okay, back on with me. Let's show this graph and click the run button. Oh, look at that. Firstly, the arrow is always going from the hottest to the coolest object, so it's always going from the outside, so it's always going from the darker colour to the lighter colour. So the arrow is going into the egg this time, and like always it's fattest at first when the temperature difference is the greatest, and then it slows right down until it gets to that 100 degrees Celsius. There's no energy flow, it just keeps the same temperature. Okay, this is the last situation. We can do exactly the same as we did before. Here we've got a loaf of bread at room temperature put into a freezer. Now the temperature of the freezer, temperature of the surroundings, is going to be less than 0. Let's put it way down to -20. The object temperature, room temperature, we're going to leave it where it is. Check that those temperatures are correct. Last question to you. Tell me again, please, or tell your teacher again, what will happen to the temperatures, both of those sliding scales? Which way will the energy flow? And when will the energy flow be the fastest? Okay, over to me again. Well, let's have the graph, and let's just press the run. Energy is flowing from the hotter object to the cooler object as always. So it's going from the loaf to the freezer, and the freezer is taking that energy away and pumping out the back. And you can see that the temperature of the loaf drops until eventually it's -20. It drops the quickest at first, thick arrow, and then thin arrow, as the temperature difference becomes less and less, and then it ends up at the same temperature as the freezer. Again, we haven't put down the freezer line because that just stayed at -20 throughout. Okay, that's the end of lesson 3. Hope you enjoyed it. Next lessons will go on to particle theory, insulation, conduction, convection, and all that kind of stuff. Thank you for taking part with this. Hopefully it's been useful. Have a look at the objectives again, and just see what you can do and what you can't do. That's great. Bye.